All right, Math 1, find the missing value using slope. So while in this lesson we're going to be using the slope formula, it's much more of an exercise on your algebra skills, on solving equations. But every single one of these problems we're going to need the slope formula. So let's write that. We're going to have y2 minus y1 over x2 minus x1, and that's our slope. Every single problem on this page, we're going to start off by doing that slope, by doing that formula. So it says that we're finding a missing value, right? So let's look at what is the missing value. Well, on number 1, it's this x right there. Number 2, it's that x. And if we scroll down, we have an x there. And number 4, we're looking for a y. So it could be both the x's and the y's that we're looking for. But again, we're going to start off by plugging into that slope. So you need to have that slope formula memorized or written down right next to you or something so that you can grab it really easy. So let's start off by labeling our points. We'll have x1, y1, x2, y2. And then we're going to plug into that formula. So I'm going to have negative 7 minus 6 over negative 8 minus x equals our slope, which it tells us is 13 over 3. Now I'm going to start off by just making this a little bit prettier. I'm going to put my 7 and my 6 together. That gives us a negative 13. So there we are. And now our variable is trapped in the denominator. So what I want to do is I want to get it out of the denominator. I'm going to multiply both sides by negative 8 minus x. Right. On the left, these guys cancel, and I'm left with negative 13 equals 13 over 3 times negative 8 minus x. Now, there's a fast way and a slow way to get this 13 over 3 out of the way. The faster way would be to multiply by its reciprocal, and that's what I'm going to show you how to do. Whenever you multiply by a reciprocal, and I talked about reciprocals in a previous video with the perpendicular slope, you multiply by the upside down version of the fraction. So I'm going to multiply both sides by 3 over 13. Now what this does is this does 2 steps in one, because normally we'd have to multiply by 3 and then divide by 13. My 3 and my 3 will cancel, my 13 and my 13 will cancel. So it gets rid of it really fast. Now on the left, if we notice, it actually works out really nicely. Our 13 and our 13 cancel. So we're left with a negative 3, because you can't lose this negative right there, equals, and then on the right we have negative 8 minus x. Now this is just a plain old two-step equation, and we're going to add 8 to both sides. We get, what is it, 8, 7, 6, 5. 5 equals negative x, and then we divide both sides by negative 1, and x equals negative 5. All right, that's number 1. Now I get that some of this is kind of long and it's kind of annoying to have to do this, but really the only, well to me, the hard part of this problem is right in here. That's where you actually have to be thinking about what are we doing, how are we solving for it. Once you get to this step here, it's just a plain old two-step equation. You should be able to fly through those, okay? So we start off up the top, writing in the formula, and then we do some fancy algebra, and then we end up with a two-step equation. So let's do that again in number 2. Number 2, I'm going to start off by labeling my points, x1, y1, x2, y2. And I'm going to have 2 minus negative 4 over x minus negative 8 equals 3 over 5. Now, just like last time, I'm going to start off by trying to make my fraction just a little bit prettier. We look here and we can see that our double negatives will make positives. So I really have 4 plus 2 is going to be 6 over x plus 8 equals 3 over 5. And now we need to actually we're in the little bracket spot on the left, where I need to multiply by the denominator. My variable is stuck in the denominator, so I'm going to multiply by it. I'm going to multiply by x plus 8. On the left side, they're going to cancel. On the right, I'm going to have 6 equals 3 over 5 times x plus 8. Now, just like last time, I'm going to do a little bit of fancy math here, and I'm going to multiply by the reciprocal. I'm going to multiply by 5 over 3. Right. So what that does is that cancels out this fraction completely. And on the right, I'm going to write down on the right side is going to be just x plus 8. On the left here, I can cancel out my 3 and my 6, and that gives me a 2. And then I have 2 times 5 is 10. Now this one actually ended up being a one-step equation, which is kind of nice. I'm going to subtract 8 from both sides, and I get 2 equals x. There we are, we're done. All right, let's look at number 3. Number 3, I'm going to start off by labeling my points again. I don't think I'm going to do this every time, but I'm going to start off doing it for the beginning. x2, y2. So I plug into my formula. I have negative 5 minus 0 over x minus negative 7. And that's equal to 5 halves. Well, we can notice that our double negative here will become a positive. Also, our negative 0 just kind of goes away. So my next step here is going to have negative 5 over x plus 7 equals 5 over 2. Our variable is trapped in the denominator, so I'm going to multiply by x plus 7. I can cancel on the left, and I'm left with negative 5 equals 5 halves times x plus 7. Now, as I've said before, there are lots of different ways to proceed from here. I think the fastest and the quickest way is to multiply by the reciprocal. So I'm going to multiply by the upside down version of this fraction there. So that is 2 over 5. And what that does is that cancels out these two guys. And on the left here, my 5 on top and my 5 on bottom can cancel. But we can't forget our negative, so I have a negative and a 2. So it's going to be negative 2 equals, and I have x plus 7. Now this is a nice one-step equation. I'll subtract 7 from both sides, and I get negative 9 equals x. There we are. All right, number 4. This one's going to be a little bit different, and I think it's actually going to end up being a little bit easier because our y is our variable here. So I'll start off by saying x1, y1, x2, y2. And now let's write our formula, or plug into the formula. So we're going to have 8 minus y over negative 4 minus 1 equals negative 8 over 5. Now notice what I did there. I took that slope, that negative, and I went ahead and put that with the numerator. I think that makes the problem a lot easier for me. So just like in all the other ones, I'm going to try to make my fraction a little bit nicer. So I'm going to have 8 minus y over, well, negative 4 minus 1 is negative 5 equals negative 8 over 5. Now, here's where I think it gets a little bit easier. My variable is already in the numerator, so I'm not going to need to multiply by it. I'm going to multiply by what is in the denominator, which is negative 5. So my negative 5 on the left cancels, and I've got 8 minus y equals, on the right here, my 5 will cancel, and my negatives will cancel. So I'm left off with a plain old 8. Now I can subtract 8 from both sides to try to solve, and I get negative y equals 0. Well, if negative y equals 0, then y equals 0. And there we are. So the big difference there was with whenever we have a y as our variable, it's going to be in the top, and it really, I think, makes the problem a little bit easier. All right, that's number 4. Number 5, yay, another one that has a y in the top. So I'm going to do this one without labeling my points, like with the x1 and the y1 thing. If you want to keep doing that, you're welcome to, but I'm going to try to do it without it. So I'm going to have y minus negative 2 over 1 minus 9 equals negative 1 over 4. Now, just like what I've been doing, I'm going to try to make this a little bit prettier. I'm going to start off by changing those to an addition. And I'm going to have y plus 2 over, well, 1 minus 9 is negative 8. That's equal to negative 1 over 4. Now, just like last one, I have a negative 8 in the denominator. I need to get rid of it, so I'm going to multiply by negative 8. My negative 8's on the left cancel. And on the right, I have a 4 in the bottom and an 8 in the top, so I can cancel 4 and 8 will cancel to give me a 2. And we can't lose that negative. Let's just put that negative right there. So now I have y plus 2 equals, and I have a negative 1 times negative 2, which gives me a positive 2. I can subtract 2 from both sides, and I get y equals 0. Now I know the last two problems have given us y equals 0, but that's not always going to be the case, and number 6 will be a good example of that. So number 6, we're going to start off by writing our formula, just like last time. We're going to have 4 minus y over 3 minus negative 2 equals 1/5. Now, just like every problem so far, I'm going to make this a little bit prettier. I'm going to change this to an addition sign there because I had a double negative. And I'm going to have 4 minus y over 3 plus 2 is 5, is 1 over 5. Now here's actually a little trick here that we can do. This is really just multiplying by 5, but it's a trick. If you notice that your denominator is the exact same thing, you can just get rid of them. And what we're really doing here is we're multiplying by 5 on both sides, and they cancel. And we're left with 4 minus y equals 1. All right. That trick also works if the numerators are the same, and we'll see if we have a problem that's like that. So now we're solving here. We can subtract 4 from both sides. So I get negative y equals 1 minus 4 is negative 3. I divide both sides by negative 1, and y equals 3. And there we are. All right, let's look at number 7. Back to the x's, a little bit harder problems. So I'm going to have negative 5 minus negative 4 over x minus negative 2 equals 1 over 5. Now I'm going to try to make this prettier. I can have a plus there, a plus there. Negative 5 plus 4 is negative 1, and then I have x plus 2. Now I'm going to multiply by x plus 2 on both sides. So I'll multiply by the denominator, x plus 2. On the left, they just cancel out, and I'm left with a negative 1. On the right, I have 1 over 5 x plus 2. Now with this being a 1 over 5, you don't really need to use the reciprocal. You can just use a plain old 5. We can imagine that that would be doing the same thing if we were to do a 5 over 1. But that's just extra to write. So this guy and this guy cancels. And I'm left with negative 5 equals x plus 2. I can subtract 2 from both sides. And negative 7 equals x. All right, that's number 7. Number 8, last one. I have negative 7 minus negative 8 over negative 1 minus x equals, the slope is undefined. Well, what does it mean if the slope is undefined? That means that we have a 0 in the denominator, right? So we can stop what we're doing and we can say, well, this thing has to add up to 0. Okay, so I'm going to stop what I'm doing. I'm going to say, well, let's look here. We have negative 1 minus x equals 0. This is the same thing as, well, let's do this. Let's add over an x, and negative 1 equals x. All right. So you see, if the slope is undefined, you say, well, that means that there's a slope in the denominator, or a 0 in the denominator, and you can just stop what you're doing and grab the denominator and say, well, this is 0. Right? That same trick works if it is a slope of 0. Right? If this were to say 0, then you could have stopped and you could have taken the numerator and made that equal to 0. All right? A little bit of a trick. All right, that's number 8.